It's pretty hard to follow flesh-eating bacteria and maggots, but I'll do the best that I can. You guys okay today? Well, again, this is the first year, as mentioned, that I've been retired from TV for 28 years. I retired from that in July, and I'd been crafting this business of mine for almost 20 years. And that business in which I speak of is exactly this, which is basically bringing long-range and seasonal forecast weather information to those that genuinely use it. From a risk management decisions to just simple day-to-day stuff, it's given me a lot more time and has freed up my schedule to do exactly what I love to do. I was in Strasbourg this morning delivering some stuff to some folks up there today. So as we go through this, you guys know the drill. You've been here. If you've got questions along the way, we'll just address those right then. And then if we have questions at the end, great. But I'm going to walk you through kind of what I believe is going to take place with the forecast over the next several months or so. And that's my business right there. So if there is something that I can do for you, I'll give you some contact information at the end. I've got a cute little website and everything that I got all set up and everything. So I'm a lot more professional now than I've ever been, and I'm not very professional as it goes. So with that in mind, let's talk about who's seeing drought and who's not seeing drought, not just locally, but across the whole country. And it has been a while since we have seen this type of green and blue across eastern Colorado and also across our immediate region, not just here in Colorado, but also across parts of Kansas, the Panhandles, northeast New Mexico. The problem with this, I guess it's a problem, is that the lion's share of that came in one storm, basically. All right? So, and that storm early in November did a tremendous amount of good to the profile as far as the subsoil moisture is concerned, because a lot of it had been depleted and we needed a good recharge like that. The good thing about that too is not only the moisture, but the ground was not frozen yet, and we were actually fairly mild through the remainder of November and December. So you really couldn't draw it up a whole lot better than what happened during that period of time. The thing is that we just kind of need to keep it going just a little bit. And this garbage that's flying around outside right now doesn't do us a bit of good because there's zero moisture content in it. So I know it's nice to see the snow out there, but it's more of a nuisance or a headache than anything else. So the worry that I have is that we are sandwiched between pretty significant dryness up here to the north of us and also this to the south and southwest. I usually don't get too concerned about this up to the north because drought rarely moves in from the north to our area. It usually comes up from the south or the south, the southwest. This is legacy drought. This has been going on for a few years here in southwest Texas, southwest New Mexico, Arizona, and right up into Nevada and Utah. And the longer this sits here, the more it gives regional dryness a foothold from which to expand. And the weather pattern overall, as I said, while it looks good, it really hasn't been very favorable down here to the south and southwest. This is Colorado, percent of normal, if you will, over the past 30 days. So right here along the median front range, Palmer Divide's doing okay. Southeast Colorado's been in horrible shape, really from Trinidad to Springfield up toward Lamar, that corridor. And that is kind of an extension of what's been going on down in New Mexico. And the western slope for the past 30 days has been shut out. Now, this pattern change that we're undergoing right now will help things out quite a bit for our mountains. We're going to see some pretty decent snow. But for areas down here in the southeast, I just don't think it's going to mean a whole lot. And if we widen that view out to 30 days, you could see what's going on. So these are goose eggs down here. That's exactly how much moisture they've seen over the past month. From southeast Arizona, most of New Mexico, west, southwest Texas, and on up into parts of Kansas. This is the remnants of a storm that happened, back in, earlier than January, something like that. And if we push this out to 60 days, you still see the same pattern. So after we got through that one storm or that little 2-week period from Halloween to Veterans Day, a lot of parts of this country have been shut out. Okay? Let's go back one. This is a problem that I am concerned about because the storm track is not favoring that region to pick up moisture in the near term. So there's going to have to be something to change for this to actually get on board here. Otherwise, all of this dryness that's down here to the south is going to continue to expand northward. Let's see what the next 2 weeks has in store for us. This is the upper level weather pattern today. So the greens and the blues up here, this is the disturbance that's eventually an extension of it that's going to swing through and give us our wintry weather over the next 24 hours or so. But this pattern is a cold pattern. I mean, it has been frigid up north across Montana, parts of southern Canada, and it's basically put the ability of Arctic air to come in pretty readily like it is outside right now. And the next 2 weeks are going to look like this, okay? We see the pattern changing not very much. It just sits and spins here. This piece of energy kicks through, comes out on the plains. Another piece of energy comes through right there as we head into Saturday. And then we just kind of recycle the whole thing all over again. So the longer this sits up here, the harder it is to break down and the harder it is for us to actually see any significant warmth because it's just doing what it's been doing for really the past several weeks or so. And I know we've had some decent breaks here and there in our backyard, but they really haven't up north. And in fact, the chill that they've been dealing with up there has actually been pretty significant, even if they haven't had a ton of snow in places. But this is the temperature anomaly forecast from today through the 18th of February. So right there in Lyman, about 12.5 degrees below average is where they're going to sit for the next week. Okay, that's nighttime low, daytime high. So the overall theme there is it's going to be quite a bit colder than average, and you don't have to go too far to the east there to see temperatures approaching almost 20 degrees below average across parts of Nebraska and into Kansas. The farther southwest you go, obviously you don't have to worry about it. But the next week, looking pretty chilly for us from now through the 18th. If we look at precipitation anomalies for that week, again, we see some better stuff happening here on the western slope, as I'd mentioned, and then out across far east central Colorado and across most of Kansas and southern Nebraska. Basically, that piece of energy comes in like this, lays down a stripe of snow, but it's really not doing anything at all down here to our south, our southwest. And the areas that have really been wet are extending from East Texas on up through the Mississippi and the Ohio Valley. They've had pretty active time of it as of late. So that's through the 18th. Let's look at what lies beyond the 18th and take us through the 25th. So next Tuesday, we've got this little piece of energy coming through, okay? And beyond that, we start to see some hope for an actual pattern change, at least a little bit here. In fact, let me put it into motion maybe. Maybe. There we go. You can see that disturbance exits, and this ridge tries to build in here from the west. All right? And this ridge might actually have a little bit of staying power to finish February and to get things going early in March. All right? So it's a little bit of a different pattern than what we've seen lately, which would kind of slam the door shut for a while on the Arctic air that's been coming down from the north and give us much more of a Pacific flow coming in here. But again, that doesn't necessarily scream wet weather. It just screams warmer than where we've been. And in terms of temperature anomalies, you still see that we're below average in terms of those temperature anomalies from the 18th through the 25th here, eastern Colorado. I think a lot of this is probably tied to early in that period. Later you go in that time frame, again, I think things will be better, obviously, as the core of the coldest air shifts its way eastward into the central plains and Midwest. In terms of precipitation, we dry things out again here in central Texas, southern Oklahoma, the southwest Colorado. And again, we don't see very much moisture during this time of year anyway, so even if you just see average, that's really nothing, okay? Especially because of the way it's snowing outside right now. That stuff has zero moisture content. So for the next couple of weeks, I would say warmer that first part of that week. That second time frame, obviously, we're cooler first and then warmer later, and then we'll see what kind of snow we can squeeze out of this. But there'll be a little bit of a change take place over the next couple of weeks. Let's look at the La Nina that's going on right now, because it's been taking place now for the past several months or so, and that's what sea surface temperature anomalies look like across the globe. Right there, for those of you that don't know what La Nina is, it is this particular part of the Pacific Ocean that ends up being colder than average. That colder than average signal right there along the equator has ramifications across the globe. These three question marks that I have right here along the west coast of North America loom large for what happens this summer. If we end up being colder than average here, where I've got them, what that does is puts a pretty stout dry signal in our backyard. We don't want to see that. If this were to warm up a little bit, that would ease our dry signal as we head through late spring and into summer. It is too early to determine what it's going to do because we haven't undergone the seasonal shift yet and seeing how things kind of settle out once we get through that. But this is going to be a significant tell to what happens not only locally but regionally here across the western and the central United States. The thing that has been taking place down here with La Nina is it's been changing. So this is the past 7 days, sea surface temperature anomaly change. You see the reds and the oranges here? That's that part of the ocean warming up at the surface. And this is the first time that it's been doing that for at least a couple of months. The other thing up here in the North Pacific and along the west coast of North America, you do see some blues in there. That means it's been slightly cooling. I don't really put a lot of stock into that just yet, just simply because it's the time of year that it is. So like I said, we need a little bit of time here to figure that out a little bit. But this, I think, is on board with changing because graphically speaking, goodness gracious, I think it just caught up. Let me see if we can go back on that. There we go. Let's do that. Graphically, if you go back here to mid-November, you could see that our La Nina came up here and was basically gone, neutral. But then since then, all we did was strengthen it to around Christmas Day. When we maxed out, we weakened it briefly again and then came back down here again in January. We bottomed out at around negative 1.5, which in the grand scheme of things is teetering on like a moderate La Nina event because of that. But since then, we've done nothing but steadily climb out of this, and our latest value is just under negative 1 degree Celsius in terms of the temperature of the water out there. I know that doesn't sound significant to most of you, but it's significant. It's significant enough to have an impact on our weather pattern, especially the way we've been dealing with it now for the past several weeks or so. But the forecast from different probabilistic outcomes, if you will, all right, take us over here in this blue bar where we are with La Nina, and we basically see it try to go away. April, May, June, less than a 30% shot of it still being present, which is a good thing. The troubling part about that is it tries to want to come back later this year. We go up to almost a 50% odds of that happening in September, October, November. I'm not entirely convinced that that's going to happen, all right? I think that we'll see things sort themselves out here in the next month or so. But I think for the heart of the warm season, we are largely going to be up here in somewhat neutral territory. It may not necessarily be as warm out there as we want it to be, because when it's warm in that region, we usually don't have to worry about moisture, all right? That's kind of the thing that I'm watching, is how quickly is this thing going to go completely away. And the Bureau of Meteorology out of Australia, looking at the same thing, is forecasting it to weaken too. You see it comes up here from the blue line. But this little sidestep business, I'm not a fan of at all. That means that the modeling is suggesting we may have a little bit of a dip here come March and April that lingers a little bit into May before we finally push ourselves above zero to stay. That little pause in its going away, I think could have a significant impact on what lies ahead for our spring. The overall state of the Pacific Ocean is cold, all right? So the fact that La Nina is present, it doesn't just want to immediately go away. There's a little bit of a hangover, so to speak, until it finally gets out of here. And I trust the Bureau of Meteorology out of Australia implicitly with the research and the stuff that they put out, because I think they do an excellent job. So when their modeling is showing this little bit of a pause here in its departure, that is something I certainly pay attention to. Okay? You'll see some of that here in the seasonal forecast update. So let's look at the modeling and see what we have to say about that. This is the upper level weather pattern as being forecast by this model for the month of February. And I know here we are at February 11th, but the remainder of the forecast period has a couple of things. High pressure right up here over the Aleutians in Alaska, low pressure down here. This configuration allows nothing but Arctic air to be able to come down into the United States. All right? And for February, this is not atypical. Okay, we can see this. But by the time we head later in the spring, I want to see this kind of pattern get out of here. And it really doesn't. In fact, for March, it kind of doubles down. The high retreats a little bit more here to the Bering Sea, and we carve out this cold trough that's here across western Canada, the north and the northwest part of the country. Now, for us this far south, you see these lines coming in basically from west to east right across us. That is not a wet signal for us. What type of signal that is we put cold air late in the season up here, and that is readily able to be tapped and moved farther south. I was in Liberal, Kansas about a week and a half ago, just west of Liberal, Dodge, Mineola over there. There's some wheat that's 12, 13 inches tall. Okay, that moisture in the fall was real nice, but that stuff didn't go dormant until January. It grew. Those guys do not want to see wheat that tall with a March that looks something like this. So from a freeze potential standpoint, I'm pretty concerned that we're going to lose some wheat to late freezes and frosts because of this configuration. Not just because of March, but also April. You still see an artifact of it. Highs up here in the Bering Sea. You still have the remnants of that trough here. Again, look at how things are coming from west to east here. Yeah, that's not a good sign right there, because the longer that pattern persists, the more that cold air can be readily tapped, even a little bit later in the spring. So it's just something that I'm bothered about. I've been bothered about this for a while, if you follow my stuff. After we get past April, I'm going to let this roll through August, okay? And you're not going to be able to glean a ton from what you're going to see here, but the one thing that I am interested in is this little weakness. You see where it goes to white right here by the time we head toward August. And what that weakness is I think it's going to allow at least some monsoonal moisture to come up here during the season when it actually should. If you remember what the past August and Septembers have been like, I mean, we've had late season heat, we've had spotty rains, so on and so forth. This type of pattern would suggest to me, if you knew nothing else, that we're going to have to worry about dry weather on the front end of this, and we'll probably get some wet weather later on, okay, or wetter weather, just because of how the upper level weather pattern is forecast to end up. So let's see if that's exactly what the model's going to say. This is the Euro-seasonal model forecast for February. A lot of this has already happened out here in the Pacific Northwest, Northern California, up across Montana. A lot of this has already happened too, but I think after we get this little blip of snow out of the way in the next 24 hours, we're going to go right back to dryness in the midsection of the country. So for February, this is one of those patterns where you're wet northwest, you're wet east. Again, this is not a good pattern to really help facilitate big storms for us that'll do a lot of good. If we go to March, it's the same type of a deal, all right? You are wetter than average north-northwest, you're dry here in the middle or drier, and then you're wetter farther east. The brown doesn't necessarily mean you're not going to see anything, all right? But it certainly tips the flavor of the forecast in the dry direction, all right? And this pattern, okay, would suggest to me that these storms come in something like this, they weaken, they skip us over, and it takes them a long time before they can get out here and tap moisture from the Gulf of America. Did you catch that? Gulf of America. They changed it on Google Maps yesterday, so it's real, right? Got to be real. If it's on Google Maps, it's got to be real. Anyway, April, same story. The farther east you get, that's where the moisture is tapped. Farther west, we struggle here. For May, same thing. And the core of that dryness is actually pushing its way farther north. I've been looking at this scenario now for a few months, and it really hasn't deviated from what I'm showing you right now. The interesting thing about this is in May, look at central and northern Mexico here. You see the greens and the blues starting to pop up here? All right? That, to me, is an indication of a couple of things. That we have early season heat right here, okay? That early season heat, a lot of times, will enable the monsoon flow to develop sooner than it otherwise would. So instead of a July feature, you speed that up and you have a June feature. Look at that tongue of moisture coming out of Mexico. All right? This isn't necessarily a good thing because it means we've got to weather some dryness before we can get this monsoonal pattern set up here. But even into June, this is not ideal right through here. The moisture here is too far to the west and southwest, and the moisture here is too far to the east. That leaves us in the middle. We've got dryness still taking place up here to the north. I would like to see this a little bit different, if you get my drift. For July, some of that moisture creeps up, moves into Colorado. Again, so it weakens the dry signal here across our state, also Utah, New Mexico. I know there's some dryness sprinkled in here, but you can still see, doesn't take too much of an imagination to see that green kind of coming up like this, like it historically should. And if we go to August, that breaks down even more. And you can see the flow coming right up like this. Okay, this little patches of brown, that doesn't bother me. We need to get the moisture in the ballpark, because if it's in the ballpark, then our mountains and the daytime heating a lot of times will take care of the rest for us. If that moisture isn't close, that really gives us some problems. And if we've got moisture, showing up here and across the panhandles, southwest Kansas, I like this feature right here, okay, to focus on. So like I said, I think I'm really happy, and I talked a lot about this back in the fall, how critical that time frame was from Halloween to Veterans Day that we actually got some water in the ground, because we were going to need it, because we need something to bridge this gap. If indeed we do have this quote-unquote La Nina hangover into the springtime, we need something to help us get through that time before it actually starts to rain. And I know a lot of folks are saying, well, this is doom and gloom. Well, I'd be a lot more pessimistic if we didn't have any water in the ground. If we didn't have that out there, we'd be in horrendous shape, because then we would have to really focus and capture whatever we get this spring and make useful. If we've got that sub in the ground, vegetation can go to work on it, then we just need a couple of timely rains to get us through. Doesn't have to be a lot. Doesn't have to be a crazy wet pattern. We don't need that in this country. It's all about the timing. So that water we have in the ground out there is certainly a blessing. Let's look at the NMME. This is the U.S.'s model ensemble that we look at. You're going to see a lot of the same characteristics that I just showed you. All right, where for March, you're drier than average here in the south-southwest, you're wetter in the northwest, and you're wetter here, eastern Corn Belt, Mississippi, and the Ohio Valley. If we go to April, the dryness starts to expand northward. I'm not so much worried about the lighter shade of browns here on the end. I'm more worried about these darker shades, all right, that come up into southern Utah, southwest Colorado, and would be along the Front Range. For May, same story. But you can see where those darker browns are positioning themselves. This dryness is no doubt migrating northward, and it has been for the past 3 months that I've seen this model. It's been very steadfast in doing so. The eastern flank of this dryness is going to be something that I'm going to be interested in more than anything. How far east does this set up? And if we look at what happened in May and then June, I'll get it to go. There we go. You can see that our dry signal relaxes a little bit here, all right? Focuses farther northwest, focuses a little bit farther east. If this sets up, this configuration, that would mean that this area of water that I talked about with those 3 question marks sets up colder than average. Because if we go to July, look where the dryness sets up. From the southern prairies of Canada, northern Rockies, northern plains, right into the midsection of the country. And while that's happening, look at the little light green here, and then also right here. So that would mean high pressure is centered up out here, somewhere in the midsection of the country, and that monsoonal moisture is coming up around that high like this. Doesn't necessarily mean it's going to clip us just yet, but I'm a lot less worried if we can get the moisture into the state, because eventually that dry signal weakens even more, for August, and it stays more focused up here to our north, all right? And if we go even farther out into September, and I know this is way out in fantasy land, but you can see where the dryness is focused up here. So this particular model is saying the same thing. Drier early, wetter later on in the forecast cycle because of that. I've already got people in the Corn Belt chirping about this forecast. And again, they have a fit if it doesn't rain every other day during the summertime up there. And so I'm trying to get them to understand what the new definition of drought should be in their backyard. All right? Because they cry about drought about every other year up there, and all they keep doing is raising record corn crops. Okay? Because of the crop genetics, there has to be a redefinition of what is considered drought in the Corn Belt. Otherwise, it doesn't do anybody any good, and the marketers do nothing but cry wolf, and then we say, oh, USDA reports record corn crop this year. Big shocker. Okay? So, but they are looking at this stuff very, very carefully up there because there are some signals that we're going to have to pay attention to for at least parts of the Corn Belt that could end up, somewhat drier as we head into this year. Okay? Questions from you all? You don't want me to advise on what type of weather day we'd want on that. No. Isn't it crazy, though? What was it? Was it last year we had to move or 2 years ago? Was it last year? Yeah. Isn't that wild? Yeah. Early February can sometimes be not so nice. That's for sure. Yeah. Mm-hmm. I think there's a shot we could enter into a weak El Nino late this year. There's a chance. I would feel much better about that transition if the Pacific as a whole would be warmer. When we're in this particular state, and I could have gone on about the Pacific Decadal Oscillation and so on and so forth today, we are in year 26 of a cold PDO cycle. Historically speaking, that cycle only lasts about 20 to 22 years. So I talked to a guy this morning, and he's like, man, he said, the past 6 years have just been awful. He said if it wasn't drought, he said it was hail. If it wasn't hail, it was freeze. And I'm like, oh, you must farm in the Western High Plains then, because that's normal, okay? But when that Pacific is in a cold state like that, it makes it real hard for La Nina events to completely disappear and El Nino events to completely come on like they otherwise would. We need the Pacific to come back to at least somewhat of a neutral state, and then I would feel a lot more comfortable about getting moisture when we're supposed to, okay? Not seeing such extreme loading of precipitation on one end and then taking it all the way on another. That's why I always said average moisture here is way too much plus not enough, divide by 2, and we never get it. That's average to me, okay? So would an El Nino event help later this year? It doesn't necessarily hurt. I'm just not – I don't think we're going to be able to pivot as fast to probably make it resonate during the growing season, okay? I felt very differently about that back in 23 when we talked here. In 23, we were coming out of this La Nina event, and it was definitely ending early. It was already done by this time, and we went full bore into an El Nino event, and we had all the moisture we wanted, we had all the hail that we wanted, and we had all that stuff going on. This is not the year that that's going to happen, okay? So slow transition, perhaps, yeah. Mm-hmm. Yes? Mm-hmm. Both? Yeah, both have a huge impact on that. Because there's not always huge amounts of geothermal energy being released. So those changes have to rely on what happens every day, which is solar, okay? But the El Nino stuff, and if you dig a little bit, you'll find some interesting things about the El Nino that happened in 2023 and early 24. And if you go back, man, I think it was January of 21, we had a huge volcano erupt, which was Hunga Tonga. That's the name of the volcano. It was an undersea volcano, all right? So it didn't have a big cinder cone. What it did is it took, to qualify this, for those that don't know, it's likely the biggest volcanic eruption that will ever happen in our lifetimes, all right? I know back then there was a lot of stuff going on. We had COVID going on, we had all kinds of stuff. But this one event did nothing but put record amounts of water vapor in our atmosphere because it came up, it evaporated all that seawater, it ejected into the atmosphere, not only at lower levels, but in the stratosphere. So for the past 3 years, we've had record levels of water vapor in our stratosphere. And once it gets up there, it doesn't like move around like it does down low, all right? So fast forward to 23, all right? That one event, in my opinion, was huge in helping facilitate that El Nino event that happened in 2023. The amount of geothermal activity that occurred from that event in the South Pacific was pretty incomprehensible in the grand scheme of things. And then when you take all the water vapor that was injected from that volcano and the ocean into our atmosphere, well, water vapor does nothing but hold heat, okay? So if we go back to the spring of 23, and I've got a stupid memory for all this stuff, okay? We had all this wet weather. Everything was doing great. What happened in August? It shut off, and it got hot. And if you go down to Texas, that summer in Texas was hot, man. It burned up all the crops, like everything. And that is I think you can tie that one event to that facilitating that. It doesn't happen the next day, okay? The atmosphere responds slowly to these types of things. But if you do something like that and help, quote unquote, artificially develop an El Nino because of a geothermal event, and then you put all that water vapor in the atmosphere, it has huge impacts. There's no doubt about it, it has huge impacts. So a long-winded answer to your question, okay? I do think that there can be events geothermally that can change, you know, how fast or how not fast, like an El Nino event can come on. Yes, I do. And that's especially true the shallower the water, okay, where you actually see those events happen in the ocean. Yeah. Thank you all.